Hello everyone, I'm Nitishas and welcome to the section of Grade 9 CBSE Physics class. Today we are looking at the chapter number 2, Force and Laws of Motion. Chapter number 2, Force and Laws of Motion. Now basically we are having two main sections in this chapter. From the name itself, you know that the main sections are, first one is related to force and second one is related to laws of motion. Then these two sections are here in this chapter, force and laws of motion. First of all, I am discussing about force and its related terms. Then we are moving to laws of motion. In laws of motion, we are having three laws related to motion. They are called as Newton's laws of motion. That is first, second and third. We are discussing first law and its related terms, then second law and its related term, and third law and its related terms. Okay, now we can go through the first section called as force. Force. Already you all know that what a force is. Otherwise, how we can define force? What's the definition of force? It's simply in your childhood days or in your first, second, third, fourth standard, etc. You studied something which can change the position of the body, or the application which can change the position, size or shape of the body, or simply it is a push or a pull. That's what called as force. You already studied that a force is that which is a push or a pull. Now I am defining it elaborately. A force is simply a physical quantity when unopposed can change the size, shape or direction of a body. A force is a physical quantity which when unopposed can change the size, shape or direction of a body. Let us consider this table as an example. If we have to move this table, we have to apply a force. To move towards this direction, we have to apply a force from this side, or otherwise to move towards that direction, we have to apply a force from this direction. That means to change the position of this table, we have to apply a force. That simply means force is a physical quantity when unopposed can change the size, shape or direction of a body. Force is a physical quantity when unopposed can change the size, shape or direction of a body. This is what called a force is, and the unit of force is the SI unit of standard unit of system of international unit of force is Newton. Standard unit of force is Newton, represented by N. Then we can define the force as force is a physical quantity which when unopposed can change the size, shape or direction of a body, and the unit of force is Newton. That's all about force. Now we are going to differentiate between balanced and unbalanced force. we are having two types of force, balanced force and unbalanced force. Now I am going to differentiate between this balanced and unbalanced force. Balanced force. I'm just delivering it using an example. Consider you and me are pulling or pushing a table from opposite directions. I am pushing this table from this direction and you are pushing this table from the opposite direction. When we are applying the force of same magnitude, that means we are applying same force. The value of force applied by both of us are same, but in opposite direction. The magnitude of the force we are applying are same, but these forces are acting in opposite direction. For example, consider this as the table. This is our table. And I am applying a force from this side. And just think the magnitude of that force is 5 Newton. And you are applying a force from this side like this. And the magnitude of the force you are applying is also 5 Newton. Then look, the magnitude of the force applying from opposite directions are same and the directions are opposite. Then the body does not change its state. It remains in its state of rest or in uniform motion. Then the forces applying on this object can be called as balanced force. If two forces acting on an object in opposite direction having equal magnitude, then the object remain in its previous state. Such type of forces are called balanced force. A balanced force cannot change the state of an object, that may be rest or of motion. It cannot change the state because we are applying forces of equal magnitude in opposite direction. It balances each other. Therefore, nothing will happen to the object. It remain in its previous state. Such forces are called balanced force. Then we can explain balanced forces are if two forces if two forces acting in opposite directions acting in opposite directions having equal magnitude having equal magnitudes simultaneously on an object. If two forces acting in opposite directions having equal magnitudes simultaneously on an object, then the object will remain in its previous state, that may be of rest or of motion. Such type of forces are called balanced forces. Such forces are called balanced forces. Such forces are called balanced forces. This is what called balanced force. Now I am defining what an unbalanced force is. What an unbalanced force is. What do you mean by unbalanced force? Taking the same example of this table, we can explain what an unbalanced force is. Just think you and me are pushing this table from opposite direction. The same condition. One difference is that we are applying forces of different magnitude. I'm applying a force from this side and you are applying the force just opposite to that side. But the forces acting on this table having no equal forces. It is of different magnitudes. Suppose I am applying a 5 Newton force from this side and in the opposite side you are applying a 7 Newton force. That means you are applying greater force. Therefore, the object will move towards the direction which is of greater force. That is, you can pull the table or push the table towards the direction of your applied force. That means I am applying lesser force than you. Here in unbalanced force, when two forces are acting in opposite direction on a body having unequal magnitudes, then the object will move towards the direction of greater force. Such forces are called unbalanced force. Such forces are called unbalanced force. I think it's clear to you. When we are applying two forces on an object simultaneously from opposite directions having unequal magnitudes, then the object will move towards the direction of greater force. Such forces are called unbalanced forces. Now going to the definition, if two forces are acting in opposite direction having unequal magnitudes, I am just clearing this, having unequal magnitudes simultaneously on an object, then the object will move towards the direction of greater force. Move towards the direction of greater force. And such forces are called unbalanced forces. Such forces are called unbalanced forces. Now, the topic related to force are complete. That means we just define what force is and the difference between balanced and unbalanced force. Now we are moving to our second section, that is laws of motion. We have three laws of motion. Now we are going to the first one, Newton's first law of motion. Newton's first law of motion. We already said that when we are applying a balanced force, we cannot change the state of the body. That means it remain in its state of rest or of uniform motion. That simply means if we need to change the state of a body, we have to apply an unbalanced force. An unbalanced external force can change the state of a body. Otherwise, it will remain in its previous state. That's what in Newton's first law of motion. If we are applying an unbalanced force, we can change the state of the body. Otherwise, the body remain in its previous state. That's simply the Newton's first law. Now we can define the Newton's first law as every body continues to be in a state of rest or of uniform motion until an unbalanced external force is applied on it. That means an unbalanced external force can change the state of the body. If the body is in rest, we can change the state of rest and make it move forward or backward by applying an unbalanced external force. And now think, if the body is in motion, then we can stop that body to rest by applying an unbalanced external force. That's what in the Newton's first law of motion. That's what Newton trying to explain using his first law. It's simply the term related to unbalanced force or the unbalanced force which can change the state of the body. Now we can define Newton's first law as every body continues to be in a state of rest. Every body continues to be in a state of rest or of uniform motion until an unbalanced external force is applied on it. Until an unbalanced external force is applied on it. This is Newton's first law of motion. Every body will continue in a state of rest or of uniform motion until an unbalanced external force is applied on it. That's what Newton's first law of motion. Here, a term is hidden in this first law. That is, every object will remain in its previous state until an unbalanced force is applied. That means if we are not applying an unbalanced force, every object will remain in its previous state. That means we all have, every object have a tendency to remain in its previous state. If we are in motion, we have the tendency to continue in motion. If we are in rest, we have the tendency to continue in the rest state. That tendency, that is a term. That tendency is hidden in this law. We have to explain what that tendency is. That tendency is what called inertia. That tendency is what called inertia. Thus, the term we are getting from Newton's first law of motion is inertia. Just by heart the term. You are asking to write the term or explain the term in your exam. That the term related to Newton's first law of motion. And that term is inertia. Simply, inertia means the tendency of an object to remain in its previous state. That may be of rest or of motion. An object in rest have the tendency to remain in the same state of rest. But an object in motion has the tendency to remain in the same state of motion. That's what called inertia is. Now we can define inertia as inertia is the tendency of an object. Inertia is the tendency of an object to remain in the tendency of an object to remain in its previous state. That's what called inertia. And we are having two types of inertia. The first one is inertia of motion. And the second one is inertia of rest. Inertia of rest. We have to explain both the terms inertia of motion and inertia of rest. Now we have to explain both the terms. We are having two types of inertia, inertia of rest and inertia of motion. First of all, I am explaining about inertia of motion. We all know that inertia is the tendency to remain in its previous state. If that state is of motion, then it's called inertia of motion. That means inertia of motion is the tendency of an object, to remain in its state of motion. The tendency of an object to remain in its state of motion. That's what called inertia of motion. Now, inertia of rest is the tendency of an object to remain in its state of rest. This is the two types of inertia we are having, and we have to look the examples of the two types of inertia, that is inertia of motion and inertia of rest. Just I am delivering two examples. When we are standing on a bus or any vehicle which is moving forward, when the bus suddenly brakes, we just goes forward like this. What is the reason for that? When the bus is moving, we are having a tendency to continue in the state of motion. That means the bus is in the state of motion. It is moving and we are standing inside the bus. So we have the tendency to continue in the state of motion. When the bus suddenly brakes, the bus stops and it goes to the state of rest. But we have a tendency to continue in the state of motion. That's why we just lean forward or we just falls forward when the bus suddenly brakes. That's due to inertia of motion. And just think, when the bus is at rest, we are standing or sitting inside that bus. When the bus starts and suddenly moves forward, we just move backward like this. What's the reason behind this? When the bus is at rest, if we are standing or sitting inside the bus, we are also in the state of rest. Bus is also in the state of rest. But when bus suddenly moves forward, it changes to the state of motion. But we have the tendency to continue in the state of rest. We just try to remain in the state of rest. That's why when bus moves forward, we just lean backward. That's two examples of inertia of motion and inertia of rest. That's all about inertia, the term we got from Newton's first law of motion. The Newton's first law of motion is actually explained on the basis of force, which we studied earlier. Two types of force, balanced and unbalanced force. From the unbalanced force, we arrive at the definition of Newton's first law of motion. From Newton's first law of motion, there is a term which is hidden in that law, and we find the term inertia, the tendency to remain in its previous state. And we are having two types of inertia, inertia of motion and inertia of rest. If the tendency to remain in the state of motion, then it is inertia of motion. If the tendency to remain in the state of rest, then it is called inertia of rest. We just deliver two examples of inertia of motion and inertia of rest. Just the difference between both inertia of motion and inertia of rest. Just look at this table and what inertia is, then inertia of motion, and then inertia of rest. The difference between these two and the examples. That's all about Newton's first law of motion and the term related to its inertia. Now, we just complete what Newton's first law of motion and the term hidden in that law, that's inertia, and just differentiate between inertia of motion and inertia of rest. And then we are going to the second law of motion, Newton's second law of motion. For studying Newton's second law of motion, we must understand a term called momentum. After defining momentum, we can go through Newton's second law of motion. First of all, I am defining what the term momentum is. Momentum, represented by the letter P. Momentum is the characteristic feature of moving object. That means an object in rest does not possess momentum. The term momentum is having only for objects in motion. That means moving object only possess momentum. Then as first point, we can write it is the characteristic property of, it is the characteristic property of, it is the characteristic property of moving objects. The characteristic property of moving objects. That's the first point. Momentum is the characteristic property of moving object. Now we have to define what momentum is. Momentum can be defined as the product of mass and velocity. You all know that an object in motion always possesses a velocity. Moving object always has a velocity, and every object has a mass. That mass multiplied by velocity gives this term momentum. That means it can be defined as the product of mass and velocity. That's our second point. It is defined as the product of, mass and velocity. It is defined as the product of mass and velocity. Now we need the equation for momentum. That is, momentum is equal to, look here, it is the product of mass and velocity. That means when mass multiplied by velocity, we get the term. Therefore, momentum is equal to mass into velocity. Momentum is represented by the letter P. Therefore, we can write P is equal to, mass is represented by the letter M and velocity by V. Therefore, P is equal to mv. P is equal to mv. This is the equation for momentum. Very, very important equation. Just by heart it and always remember it in your mind. P is equal to mv. P is momentum and momentum is equal to mass into velocity. Now we need the unit of momentum. Unit of momentum is equal to mass into velocity. You know the unit of mass as kilogram and the unit of velocity is meter per second. That is unit of momentum is kilogram meter per second. That's all about momentum. Just recollect it. It is the characteristic property of moving object and is defined as the product of mass and velocity. Equation P is equal to mv and unit is kilogram meter per second. Now we are clear about the term momentum and thus can easily go through Newton's second law of motion. Yes, that's our second law, Newton's second law of motion. Newton's second law of motion. This is the law related to the term momentum. We are already discussed the term momentum. In this law, it is related to force and momentum. Force is already our first topic and we discussed it clearly. Now we also gone through momentum. Thus the two terms are familiar to us, force and momentum. The law relating these two terms is the Newton's second law of motion. Now we can look how these two terms are related or how these two terms are connected by Sir Isaac Newton. Newton states that the rate of change of momentum of a moving body is directly proportional to the applied force and the direction is in the direction of force. That means the object will move in the direction of applied force. We all know that moving object always possesses momentum. Therefore, that object has a momentum and the rate of change of that momentum is directly proportional to the force. That means if we increase the force, rate of change of momentum also increases. And if we decrease the force, rate of change of momentum also decreases. That's Newton's second law of motion. Thus, it can be stated as rate of change of momentum is directly proportional to the force and it is in the direction of force. Rate of change of momentum is directly proportional to rate of change of momentum is directly proportional to force and it is in the direction of force. This is Newton's second law of motion. Now we have to derive the mathematical formulation of second law. From Newton's second law, we get an equation that is F is equal to ma. We have to derive this equation F is equal to ma. That's a sure short question for you. Mathematical expression for Newton's second law. Otherwise, derive the equation F is equal to ma. It's a sure short question. Please listen carefully. Now we are going to derive that equation, that is F is equal to ma. That's what called mathematical formulation of second law. Now I am going to derive the equation F is equal to ma. For that, just consider an object having mass m moving with a velocity u. If we are applying a force F to the same object, it changes its velocity to v. This is our condition for deriving F is equal to ma, or mathematical formulation of second law. Okay, consider an object of mass m moving with a velocity u. If we are applying a force F to the object, it changes its velocity to v. Now we have to derive the equation F is equal to ma. By Newton's second law, we are having the statement rate of change of momentum is directly proportional to the force. So first of all, we have to find the rate of change of momentum. For rate of change of momentum, we have to find the change in momentum. For finding change in momentum, we need initial and final momentum of this moving object. So first of all, I am going to find the initial and final momentum of this object. That is initial momentum is equal to, we all know that momentum is the product of mass and velocity. Here mass is m and initial velocity is u. Therefore, initial momentum can be written as mu. Then I am going to find the final momentum of the object. That is final momentum is equal to same mass into velocity, that is mass is a constant m and velocity changes to v. Therefore, final velocity is v and final momentum is m into v. Now we can find the change in momentum. Just subtract the initial momentum from final momentum. That will give the change in momentum. That is change in momentum is equal to final momentum minus initial momentum, that is mv minus mu. That is change in momentum. Final momentum is mv and initial momentum is mu. Therefore, change in momentum is mv minus mu. Now we have to find rate of change of momentum. Rate of change of momentum. We are having change in momentum as mv minus mu. The rate simply indicates that divided by time. That means rate of change of momentum indicates that change in momentum divided by time. Rate of change of any quantity means change in that quantity divided by time. Rate of any quantity means that quantity divided by time. Here rate of change of momentum simply indicates that change in momentum divided by time. We have change in momentum as mv minus mu divided by time is represented as t. Look, in the numerator, we are having mass as common term, mv minus mu. In both terms, we are having mass as common term. Therefore, I am taking mass as common, m. Then the remaining as v minus q divided by t. Now look, you are familiar with this v minus u by t. In the first chapter, motion, we already explained this v minus u by t as acceleration a. Therefore, this v minus u by t can be replaced using acceleration a and can be written as ma. V minus u by t is replaced by acceleration a. Therefore, it is ma. Then by Newton's second law, the law states that the rate of change of momentum is directly proportional to force. Thus, we can write by second law, force is directly proportional to rate of change of momentum. Force is directly proportional to rate of change of momentum. Now I am rubbing the initial condition and continuing the derivation. Force is directly proportional to rate of change of momentum. Force is represented as F and is proportional to rate of change of momentum is ma. That we get an expression. It cannot be called as an equation because there is no equal sign between LHS and RHS. LHS means left hand side and RHS means right hand side. Therefore, to make it as an equation, we have to multiply a constant. That means to change the proportionality sign to an equal sign, we have to multiply a constant. Now I am multiplying a constant. F is equal to constant k into ma. Here k is the constant and is called force constant, where k is a constant, where k is a constant called force constant, where k is a constant called force constant. Now we got an equation F is equal to k into m into a. By substituting the value of force constant, we get the final equation. I am giving the value of force constant as k is equal to 1. That is, force constant is taken as unity. Force constant is taken as unity. Therefore, we get the equation as F is equal to 1 into ma. That is, F is equal to ma. This is the mathematical formulation of Newton's second law. That is, rate of change of momentum is directly proportional to the force. That's a statement for Newton's second law, and we got the mathematical formulation as F is equal to ma. That means when mass multiplied by acceleration gives the force applied on that object. When mass multiplied by acceleration gives the force applied on that object. This is the mathematical formulation of second law. When you are asking the same question in your board exam, derive the mathematical formulation for Newton's second law. Just starting from the condition that an object moving with an initial velocity u, when a force is applied, it changes the velocity to v. And then starting from the initial points as we have to find the initial momentum, final momentum, then change in momentum and the rate of change of momentum, and then it is proportional to force. Then to remove proportionality sign, multiply a constant, force constant k having value 1. Then we got the final equation as F is equal to ma. Just recollect it in your mind what all steps we are moving through to derive the final equation as F is equal to ma. That's very, very important. All the steps are necessary. Just note down the steps I am writing in this board and just study that. These all steps are necessary for the examination point of view. So you need to write all the steps. You get full marks, no worry, don't worry. That's what called Newton's second law of motion and mathematical formulation of second law. We just complete the Newton's second law of motion and the mathematical formulation of second law, and moving to the last section of this chapter, that is related to Newton's third law of motion. We are moving to Newton's third law of motion. Related to Newton's third law, we have to explain recoil of gun and conservation of momentum. That means in the last section, we are having three topics. We are discussing three topics in the last section, that is Newton's third law of motion, conservation of momentum, and the recoil of gun. Now, moving to Newton's third law of motion. This is very simple law among the three. You all heard about this law. At least you all heard about this law from this first, second, and third law. This law simply states that for every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. When you are walking through a road and you just hit someone without any reason, just think what happens. The man you hit will surely give you a very big shock. That's what called a reaction. When you hit someone, he just reacts and give it back to you. When you are giving that action, you get the reaction. That's what called, simply we are saying, for every action, there is an equal and opposite reaction. That is Newton's third law of motion. For every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. That means action and reaction are equal and opposite. Thus, we can write action equal to minus reaction, or action equal to negative reaction. This is what called, they are equal and opposite. Now arises a question in your mind. You all know that every terms which are equal and opposite cancels each other. Simply 1 plus minus 1 equal to 0. X plus minus x equal to 0. Minus 2 plus 2 equal to 0. These are all mathematical terms. Just I am using examples, I am explaining. 1 plus minus 1 is equal to 0, you all know. X plus minus x is equal to 0, or minus 2 plus 2 is equal to 0. These are all numerical terms, which is saying that equal and opposite terms must cancel each other. In Newton's third law, Sir Isaac Newton is saying that action and reaction are equal and opposite. Then why don't they cancel each other? There arises a question, and you get this question in your board exam. Action and reaction are equal and opposite, yet they do not cancel each other. Why? Note this question. It's an important question. You will surely get this in your board exam. Action and reaction are equal and opposite, yet they do not cancel each other. Why? Simply we can say the answer as this action and reaction is happening in two bodies, not in a single body, not in a single object, but they are of different objects. Action and reaction are happening in different objects. So They do not cancel each other. Simple. That's what Newton's third law of motion. For every action, there is an equal and opposite reaction. That is, action and reaction are equal and opposite. That is, action is equal to minus reaction. They don't cancel each other because they are acting in different objects or different bodies. That's Newton's third law of motion. Now, the second last topic of our last section, that is conservation of momentum. Conservation of momentum. In this topic, conservation of momentum, that means when the momentum is said to be conserved, that's the question. When the momentum is said to be conserved, the momentum is said to be conserved. That means in the absence of an external force, the total momentum of a system remains constant. In the absence of an external force, the total momentum of a system remains constant. That's what called conservation of momentum. In other words, we can say that in case of colliding objects, if two objects collide each other, then we can say that if the momentum before collision and after collision are same, then the momentum is said to be conserved. That means total momentum before collision and total momentum after collision are equal, then the momentum is said to be conserved. Otherwise, we can say that in case of using a gun, we are using a gun and firing a bullet. If the momentum before firing and the momentum after firing are equals, then also momentum is said to be conserved. That means total momentum before an event happens is equal to total momentum after that event. Then the momentum is said to be conserved. That's one definition. Otherwise, we can say that in the absence of an external force, the momentum of a system remains constant. These two are the statements that we can write for conservation of momentum. These are the two statements for conservation of momentum. First one is, in the absence of an external force, the total momentum of a system remains constant. Otherwise, we can say that for colliding objects, total momentum before collision is equal to total momentum after collision. Okay. Now, we have to prove this conservation of momentum using Newton's third law. We are proving the statement. That means total momentum before collision is equal to total momentum after collision. I am trying to prove this using Newton's third law, that is, for every action there is an equal and opposite reaction, that is action equal to negative reaction or action equal to minus reaction. That is proof of conservation of momentum. This is a derivation and I need the whole board to write the derivation in one stretch. Therefore, I am rubbing all these written in the board and try to derive this whole equations in one stretch. Just dividing it into two, and we are going to prove the conservation of momentum. Consider two objects having masses m1 and m2. Let the first object be named as A and second one is named as B. First one is named as A and second one is named as B. First one is moving with an initial velocity u1 and the second one, that is B, having mass m2, is moving with an initial velocity u2. And just consider a condition u1 greater than u2. if the velocity of A is greater than velocity of B, then surely A will collide with B. A will collide with B. After some time, A is going to collide with B. After collision, the velocity will changes to V1 and V2. This is our condition. Using this condition, I am deriving or proving the conservation of momentum. Look the condition once more. Consider two objects A and B having masses m1 and m2 moving with velocities u1 and u2. If u1 is greater than u2, then surely A will collide with B and the velocity changes to v1 and v2. Now we have to prove the total momentum before collision is equal to the total momentum after collision. Now we have to prove the total momentum before collision is equal to the total momentum after collision. Okay, let's start the proof. Initially, I need the initial momentum of A and final momentum of A, and then the change in momentum of A. That means we have to find the rate of change of momentum of A and the rate of change of momentum of B. Then by Newton's second law, we are having rate of change of momentum is directly proportional to force. That means force applied by A on B when two objects collide each other. That means here A and B collides each other. When two objects collides each other, A will exert a force to B, and at the same time B will exert a force to A. These forces are equal and opposite. That's what we are trying to prove. Then A will apply a force to B and B will apply a force to A. These forces are equal and opposite. Then the rate of change of momentum of A is the force which A applied to B. Similarly, the rate of change of momentum of B is the force applied by B on A. So basically, we need to find the rate of change of momentum of A and the rate of change of momentum of B. Just starting the derivation. Initial momentum of A. Initial momentum of A is equal to m1 u1. Okay. Then final momentum of A. Final momentum of A. That is m1 v1. You already knows that momentum is the product of mass and velocity. Therefore, for initial momentum, it's m1 u1 and final momentum is m1 v1. Now, change in momentum. Now, change in momentum equal to m1 v1 minus m1 u1. That is, final value minus initial value always gives the change. Therefore, change in momentum is equal to m1 v1 minus m1 u1. Now, rate of change of momentum. Rate of change of momentum. We know that to find rate, we have to divide it by time. That is, change in momentum divided by time gives rate of change of momentum. Change in momentum is m1 v1 minus m1 u1 divided by time gives rate. That is equal to m1 v1 minus m1 u1 divided by time t. This is the force applied by A on B This is the force applied by A on B. I just take it as F12. Thus, we can write F12 is M1 V1 minus M1 U1 divided by T. This is our first needed equation. Put it as equation number 1. Put it as equation number 1, that is F12. We got F12 as M1 V1 minus M1 U1 by T. Similar way, we have to find the rate of change of momentum of B. Similar way, we have to find the rate of change of momentum of B. We are going to derive a rate of change of momentum of B. I am just rubbing in this and changing. Rate of initial momentum of B is equal to m2 v2. We already know that mass of B is m2 and initial velocity is u2. Therefore, we can write initial momentum of B is equal to m2 u2. Then final momentum of B can be written as m2 v2. It is m2 v2. Then change in momentum of B can be written as m2 v2 minus m2 u2. Then the same way, rate of change of momentum, that is change in momentum divided by time, that is m2 v2 minus m2 u2 divided by t. This is the force applied by B on A, that is we can write it as F21. This is the force applied by B, that is F21. F21 can be written as m2 v2 minus m2 u2 divided by t, that is time, and this can be taken as equation number 2. Now we are having two equations, F12 and F21. I am just writing these two equations again, F12 and F21. Okay, now we are having two equations, F12 as m1 v1 minus m1 u1 by t, and the second equation as F21 is equal to m2 v2 minus m2 u2 by t. These are the equation we are having, F12 and F21. Then by Newton's third law, for every action there is an equal and opposite reaction. When A collides with B, A applied a force to B, that is the action. At the same time, B will apply a force to A. That's what the reaction. That means the force applied by A on B is equal and opposite to force applied by B on A. Then by Newton's third law, by Newton's third law, we can say that F12 is equal to minus F21. That means F12 is the action and F21 is the reaction. F12 is the action and F21 is the reaction. Now I am rubbing the initial conditions and writing the remaining section here. F12 is equal to minus F21. We are having value of F12, that is m1 v1 minus m1 u1 divided by t is equal to, we are having value for F21 as m2 v2 minus m2 u2 by t. By Newton's third law, it is of negative sign. Therefore, I am putting a negative sign. Then m2 v2 minus m2 u2 divided by t. Okay. In both the equations, in LHS and RHS, both LHS and RHS having divided by t, the same term. Therefore, we can cancel the denominator t. I am cancelling both sides denominator t. Then we can write m1 v1 minus m1 u1 is equal to, here we are having a negative sign as common, and just opening the bracket we get minus m2 v2. This negative and this negative becomes positive. Negative into negative becomes positive. Therefore, this minus sign combines with this minus sign and becomes positive, plus m2 u2. Now, I am just shifting this minus m1 u1 to the right hand side and shifting this minus m2 v2 to the left hand side. Then we can write m1 v1, which is already here. This minus m2 v2 comes to the left hand side and becomes plus m2 v2 is equal to, in the right hand side there is already m2 u2. This minus m1 u1, that is negative m1 u1, comes to the right hand side and becomes plus m1 u1. Okay, just I rearrange this equation as m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. I didn't make any change, just rearranging. This is written in the left side and this is written in the right side. That's only I do with this equation. I did in this equation. Now look at this equation. m1 u1 plus m2 u2. What is this? m1 u1 is the initial momentum of A. m2 u2 is the initial momentum of B. Then m1 u1 plus m2 u2 gives total initial momentum. m1 v1 is the final momentum of A and m2 v2 is the final momentum of B. Then m1 v1 plus m2 v2 gives the total final momentum. That means in the left hand side we are having total momentum before collision, and in the right hand side we are having total momentum after collision. That simply means total momentum before collision is equal to total momentum after collision. That's what called conservation of momentum. This is the proof for conservation of momentum. Now we proved it. We proved the conservation of momentum. That is total momentum before collision is equal to total momentum after collision. Or in the absence of an external force, total momentum remains constant. That's what called conservation of momentum. Okay, now moving to the last topic of this section and also the last topic of our second chapter, force and laws of motion. Just simply an application of Newton's third law. Just simply an application of Newton's third law, that's a recoil of gun. That is called a recoil of gun. It's a simple topic. You can understand it very easily. A recoil of gun. If you are asking to explain an application of Newton's third law, then you can write recoil of gun. Recoil of gun. Just consider a gun. Just consider a gun. Not at all good on reading, John. Just don't criticize my drawing. I'm just trying to do what you have to study. Okay, now just consider this as a simple gun. And when we are firing, the bullet goes on this path. Okay, consider a simple bullet. This is our bullet. Okay. Then by conservation of momentum, we already know that total momentum before collision is equal to total momentum after collision. In case of firing a gun, we can say total momentum before firing should be equal to total momentum after firing. Okay. Then the gun having a mass, and representing this as mg, mass of gun. Okay. Then bullet having a mass of mb, and the bullet moves with a velocity vb. This is the velocity of bullet. And when we are firing, at the time when bullet moves forward, the gun will move backward, and that's what called a recoil of gun. When we are firing a shot, at the time of bullet moving forward, the gun will move backward. That's what called a recoil of gun. When soldiers are using heavier guns like AK-47 or other machine guns, they are holding it in their shoulder. If it is holding in front of the shoulder, when they are firing, it comes back and it may get injury to the shoulder. That's what they are holding tightly to their shoulder to avoid the injury caused by recoil of gun. Simply recoil of gun means when we are firing, the bullet moves forward and the gun will move backward. That backward motion of the gun is called recoil of gun, and the velocity with which gun moves backward is the recoil velocity, and I am representing the recoil velocity as Vg. Now look, mg is the mass of the gun, mb is the mass of the bullet, Vg is the velocity of the gun, and Vb is the velocity of bullet. Now we know that total momentum before firing should be equal to total momentum after firing. I'm going to find the total momentum before firing. Before firing, the bullet is at rest and the gun is also at rest. Therefore, total momentum before firing is equal to 0. Nothing will move. Momentum is the characteristic property of moving object. Bullet is in rest and also gun is in rest. Therefore, no momentum, and total momentum before firing is 0. Now total momentum after firing. Now the bullet will move forward and gun will move backward. And we can write the total momentum after firing. That is the momentum of the bullet plus momentum of the gun. Momentum of the bullet is mb plus momentum of the gun is mg Vg. Okay. Since the gun is moving backward, that's the opposite direction of bullet, I'm putting a negative sign. This negative sign indicates that the gun is recoiling. That means the gun is moving backward. Just shifting the negative term to the left hand side, we get mg Vg is equal to mb Vb. This is the condition. Total momentum before firing is equal to total momentum after firing. From this equation, we can find velocity of gun, velocity of bullet if three terms are given. That means mass of the gun, mass of the bullet, and velocity of gun are given in the problem, then we can find velocity of the bullet. If velocity of bullet, mass of the bullet, and mass of the gun are given, then we can find the velocity of gun. If any three terms are given, then we can find the fourth term. That's what called recoil of gun. That's the finishing topic. Thus, we have finished our second chapter, force and laws of motion. Now, we have to recollect what we have learned completely in this chapter. What we have learned completely in this chapter. Just listen. I am recollecting what we have learned. Force laws of motion. These are the two topics we are discussed in this chapter. In force, we discussed two things, that is balanced force and unbalanced force. Balanced force and unbalanced force. In laws of motion, we are having three laws. The first one is Newton's first law of motion. Newton's first law. In the Newton's first law, we arrive at a term called inertia. We arrive at a term called inertia. And the second topic we discussed in laws of motion is Newton's second law. Newton's second law. Newton's second law. In the Newton's second law, we get a term called momentum. We get a term called momentum. Now, the final topic of this chapter is Newton's third law of motion. Newton's third law of motion. And from Newton's third law, we are having an application, a recoil of gun. From Newton's third law, we are having an application of a recoil of gun. This is what all about this chapter. Just look this table. This is what all important in this chapter, and you have to learn all these topics. Force, from force, we have two topics, balanced and unbalanced force. Laws of motion, we are having main three laws, Newton's first law, second law, and third law. From first law, we are getting a term inertia. From second law, we are getting a term momentum, and from Newton's third law, the application which can be asked in your exam, that is a recoil of gun. That's what all about second chapter in physics grade 9, force and laws of motion. And I am Nitishas, and thank you for joining me in this section. Let us meet with another section in another day. That's all. Thank you.